This is Britt Caswell with another example video. In this video, I'm covering example 3 from section 3-5 in the SavvasRealize Algebra 1 textbook. So what we're doing is we are working on writing the equation of a trend line. So in this video, I'm going to show you how to do it by hand. In my next video, for example 4, I'm going to show you how to do it on Desmos. So firstly, we need to draw a trend line, right? So this is asking what trend line models the data in the scatter plot. It roughly looks like this, right? Maybe. Who knows? So I have one point here that crosses the line. There's another point here. My line's a little not straight, right? So might need to straighten that out a little bit. Alright, so it looks like I'm using a slope of about 1. So I can do y equals mx plus b if I want to extend this over to the y-intercept, because there I can see it's at 50. Okay, now my slope, right, is going up one box and over one box. But remember, each of these boxes is worth 50. So I'm rising by 50, and then these ones, each box is worth 2, and I'm running by 2. So my slope is 50 over 2, which is 25. And then again, my y-intercept is right here at 50, so I can write the equation y equals 25x plus 50. Another thing you could do, right, is you could do, you can use point slope form as well. So say you don't have your intercept, but you can do this formula if you really want to. I'm not going to in this example because I was really close to my intercept, but that's another thing you can do as well. Okay, it doesn't matter which one you choose. So now this one specifically states to write the trend line in slope-intercept form. So on this one I have to use the y equals mx plus b. Alright, so I'm going to go ahead and attempt to draw my line. And I'm looking for points where I may have crossed. So it looks like maybe right here to right here. And so then we have to check the scaling on our graph. So notice that it's going from 60 to 64. So each box is worth 2 going up. So my rise, or my fall really, because from left to right I'm falling, is 4. And then here, our boxes are counting by 1s. So my run is 3. So my slope for this is I'm falling by 4 and running by 3. So it's negative 4/3. Now my y-intercept is a little harder to see, isn't it? If each of these is worth 2, that would put this one at 70. So I'd say that my y-intercept is about 71. So it looks like my trend line would then be negative 4/3 x plus 71. And notice that negative slope is talking about that negative correlation, which is kind of nice. Right now who's to say that that's the best trend line? You know, so that's why we need to use technology to help us to pick what would be best, right? Like I could instead use this trend line, that blue one. Who's to say that the red one's better than the blue one? See what I'm saying? So that's why we need technology to assist us. So then this one says, explain why there could be no points on the trend line, yet the line still models the data. Right, so say that none of the points were touching my line. Okay, now the data is an estimate. I'm sorry, the trend line is an estimate. Okay, so if you are estimating, you're just guessing values that are really close So the values are very close to the data point, or to the real value, but not necessarily exact. Okay, so if you have some points above the line and some points below the line, they kind of cancel each other out, is kind of what I'm trying to say there. But there we go. So that's how to kind of estimate a trend line by hand. Like I said, you're never going to get a real good one when you do it by hand. So in my next video, it'll be with technology. Until next time.